So parallel lines are those lines that have the same gradient as each other. So for example, we can see these two lines have the same gradient as each other, and from the direction of this line we can see that the gradient will be negative. So how do you know that? Well, just to draw rough sketches here. If the line is going like this, almost upwards, the gradient will be positive, right? And if the line is going like this, downwards, the gradient will be negative. Okay, now with these two parallel lines, we have a problem. We have the equation of this blue line over here, but we do not have the equation of the red line. So to find the equation of the red line, we must rearrange this blue line's equation into a more tangible form, which would be y is equal to mx plus c. We can work with that, but right now we do not have this in that form. So let's bring it into that form. You have 6x plus 3y minus 2 is equal to 0. Then we can make this into 3y minus 2 is equal to negative 6x. Then we can say 3y is equal to negative 6x plus 2. And then we can divide both sides of this for equation by 3. And we get y is equal to negative 2x plus 2 over 3. Right? Now we have this in the form of this, y is equal to mx plus c. From this, we can say that m is equal to 2, is negative 2, right? As I said before, the m would be negative 2. Now we have the gradient of the blue line, and because of that, we now have the gradient of the red line since these lines are parallel. Now we can proceed to finding the equation of the red line. Since we have a point on this line, 0, 3, we know the y-intercept. This c part is equal to the y-intercept, and we have that due to 0, 3. So we know that for this line, when we write this in the form y is equal to mx plus c, the c would be 3, and the m, because these lines are parallel, would be negative 2. And thus we have the equation of this line, y is equal to negative 2x plus c, plus 3, sorry. Okay, so the equation of the red line is y is equal to negative 2x plus 3. So what do we learn from this? We learned that parallel lines always have the same gradient. Okay, so I'll just write that. Parallel lines, so we'll actually write it like this. So this means parallel lines have the same gradient. So their gradients are equal. Okay, the gradient of two parallel lines is always equal. We also know that if you have the gradient of one parallel line, you can find the gradient of another. You also have the gradient of the other parallel line. And then if you have even a single point on this line, you can find the equation of that line. And that is about it for parallel lines.